Hello everyone, welcome to the Data Engineering YouTube channel. So this is your fast track guide to your SQL journey in the next 30 days. Okay, so in the next 30 days we will start with the basics of the SQL, like all the conditions and advanced topics, right? So each day you will get a video about a particular topic on the SQL. So whether it is for the data analysis or reporting or for interviews. So by the end of the 30 days, so by the end of this series, you will be confident in writing the real world SQL queries. So let's get started. Before going into that, so this is the key concepts that we are going to cover about the databases, DBMS, and how SQL works and SQL commands and how what is SQL architecture and what are the interfaces and tools that we are going to use in daily on regular day-to-day life, and what are the types of SQL. So we have different types of SQLs, and we have joins and advanced joins and all the advanced concepts. And in this series we are going to learn about the T-SQL as well, and the stored procedures and error handling, right? Error handling and query optimization. And at the end of the 30th day, I will be going a large project. So we are going to a real SQL project. So end to end. So the domain, whether it is a healthcare or whether it is a retail or if it is a supply chain, we are going to decide at the later stage. And for now on, we just get started. So as part of day one, we are going to introduce about the data. So we have been hearing this word data for a long time. What is the data? What is so there is a lot of stuff behind this data. So it's nothing. So data is nothing. So we hear about this all the time. But what does it actually mean? So data is simply an information or facts, like whether it is a number, your phone number, or your email, or your email address, or your TikTok account, or your Amazon account, like this. So it can be in any form, maybe in numbers, or in words, or in images, sometimes in videos, anything, anything that helps us to understand or make our decision. So example, you buy a phone or a pen in an Amazon. So what you going to do? So we going to search the product, and then we go through the reviews and what is the quality and what is the specifications, everything. This everything is a data, and your name, your birthday, right? And as I told in Amazon, your shopping history is always a data. And in Instagram, so we have been in the Instagram for a long time, and in LinkedIn, right? So all these likes, comments, and your profile information and your resume, everything is a data. So now imagine for a big company like a Rapido or a Uber or Gojek. So they collect millions and millions of data points every day. But how you collect these data points and how you store this? This is a raw data. So you collect at every point of time. You collect the trash. Example, you collect the trash and you store and you do it, right? So this is where the data engineers play a very crucial role. The main responsibility of a data engineer is to collect the data, and you need to clean and you need to segregate the data into different chunks and then organize the data. So I will give you a clear example. So let us say you buy a vegetables from a market, right? And you bring it to your home. So you have vegetables, you have fruits, you have medicines, everything you have in a single bag. So that's a raw data. So how you segregate that? So you keep your meat in the freezer and you keep your vegetables in the yeah, in the fridge, in the locker, and you keep your drinks or anything in different racks, right? So this is how we organize the data. So our data engineer responsibility is to collect the data and this clean this data. So what is cleaning? So when you buy these vegetables, not all the vegetables are in good shape. Some might be spoiled and or some might be damaged. So you want to remove them from the fresh vegetables. So this is what cleaning means. So we organize that similarly in the data. So we have a lot of unwanted data or or corrupted data. So we don't want the data into our warehouse, right? So when we get this clear data, these analysts like data analysts and these machine learning engineers and these AI systems, they can use this data to make the smart decisions. So data, it is the backbone for every application, every website, and even in business today. If you understand the data, you can build the future. So knowing about the data is very little. So example, you find a person age. So knowing that age, it tells nothing about that. So when your data, it is used to answer a particular question or use it to filter, you filter the people at the age of 29, or you want another filters, or you, if you want an answer to a particular question, then this data is useful, right? And without the data and how you extract this data, how you save this data, you cannot do it everything manually or write in a paper for a large chunks of data. You can write for a couple hundreds of records, but what if it is a millions of records and billions of records, right? So this is where our data tools come into place, especially SQL, right? So this particular tool, this turn the raw data into a useful information. With without these tools, our whatever the data that we are collecting is just a noise. Like we don't know what to do with that particular data. With these particular tools, our data becomes a knowledge. Like as I said, this is a knowledge. So what is the types of data? So our types of data, there are basically three types of data: structured data, semi-structured data, and unstructured data. What is a structured data? So structured data is like we store everything in the form of Excel files, like a rows and the table, right? So example, the name Pawan, you have his age, you have his occupation, you have his salary, and you have his hobbies, like this. So every data has qualitative and quantitative measures. Like everything in numerical information, it comes to quantitative, and descriptive is qualitative. Like the salary comes under quantitative, and all the remaining things comes under qualitative, right? This is how the raw data looks like, and when we organize it into a particular thing, and it looks as a meaningful data. So this is the SQL is the best for the structured data. It is mainly used to organize the structured data. And then what is semi-structured data? So semi-structured data, we have formats like JSON file and XML file. We have a flexible structure over here, but they are not arrays tables. So these some SQL tools are evolving into this semi-structured data. Example, Snowflake. Snowflake supports this semi-structured data, right? So and then what is unstructured data? So the name itself, it says it doesn't have any structure. It can be in any form. So it's unorganized. Think of about this emails and images, social media posts, videos, PDFs. This doesn't follow a clear format, and it's harder to analyze without specific tools. So we use tools like MongoDB, Cassandra. So these are the NoSQL tools. NoSQL tools, but that means it is used to analyze the unstructured data, right? And now we are going into the databases. So what is a database? What is a database? So a database is it's a kind of digital warehouse for storing and organizing your data. There are many types of databases, right? So these databases are designed to handle a large amount of data, right? So they have relational databases and they have uh, non-relational databases. So these relational databases majorly they store the structured data. So structured data has like example SQL, MySQL, Oracle, SQL Server, PostgreSQL. So these are the examples of relational database system, and this SQL is the language that we use to interact with these kind of databases. So what is SQL? It's basically a language, just like a programming language. It's a query language. We use it to talk with these databases. So example, you are a Indian national, I am a US citizen or a UK citizen. So how we interact? You have different language, we have different language. So we have a common language, English. We interact in English to know to communicate with each other. Just like that, just like that. So primarily we have these three kind of databases. So majorly, so the relational databases, which are DBMS, and then NoSQL databases, which maintain the unstructured data, and we have these cloud databases, like Amazon Redshift and Azure SQL Server and BigQuery, right? So these are the three major cloud databases. Apart from this, there are many other types of databases like hierarchical databases. So it's like a tree kind of structure. So I mean, each record is linked to different records, potentially many children. Like you see most of these things in semi-structured data. So the best example is an IMS, so which is the which is the database used by IBM. So mostly when we have this kind of large kind of organizations, they use their own databases like IBM and like Cognizant, right? So these are the other types of databases. And the next kind we have is NoSQL databases. So in these NoSQL databases, we have different kinds of NoSQL databases. Like the document store. So it stores basically the documents, like the PDFs or some JSON files. So the best example we can think of is MongoDB, right? And you have another values like key value pairs. Key value pairs is like you have a key. For example, you have one key and you have different pairs. Example, we have a car, right? So a car can be from Audi or from BMW or from Bench or from Toyota. So these are the basically everything is a car. That's a key. And these IBM, these companies are different values, right? And we have these columnar storages. When we say columnar storages, so it stores data in the form of columns rather than in rows. So when we pick a particular record, it search to that particular column and it filtered through that. The best example is Cassandra and HBase. And we have graph databases, and we have network databases, and we have object-oriented databases, and we have in-memory databases. So in-memory databases is like when we store the data, it's directly stored in the memory. It's rather than storing in the storage, right? So when we want some data very fast, like for the transactional databases. So this the best examples for the in-memory database are Redis and Memcache. So these are used for the real-time applications, the streaming data. And we have some distributed databases. So distributed databases is common nowadays. So like the data is distributed across multiple nodes. So if one node fails, you get data from another node. So as I said, we have these cloud databases. So we use mostly nowadays 80 to 90% of the data that we are dealing is in the cloud databases. So the traditional databases are being migrated to the cloud database. And what are the key concepts of database? And the next we can go to this DBMS, database management system. So what is this DBMS? So the database management system, it's actually a software that is used to store your data and keep your data safe. And we can work with that particular data all the time. So the examples that we have are MySQL, PostgreSQL, and SQL Server, Oracle. These are the kind of on-premise databases. On the cloud side, we have Azure SQL Database, and in AWS we have this Amazon Redshift, and Google we have BigQuery. So these are the database management systems. So why we need these databases? So because these systems allow you to insert, update, and delete and read the data, but they need instructions. Why they need instructions? And these cloud database, why we are going to the cloud databases? So these cloud databases, we can access everything at anywhere. If one node fails, we can get it from another place, like that. So how we instruct these software? We use a language called SQL, Structured Query Language. It is a it is a query language which is used to talk with this particular software, DBMS software like SQL, PostgreSQL, SQL Server, and it is used to communicate with this database. Let's assume like it's a kind of translator. You go to some other country and you know the language, you get a Google translator or some human translator. You translate between these two terms and get the data exchange. Right? So you ask questions to it, and it gives you the results. So the example. So let us say we have a user table. So you instruct SQL to get all the details from the user table. So you just write a query like select all from users. That means you are telling the SQL to get the information of all users from the table. And this query can be further optimized. So you don't want all users, you want users who are just active. Then you filter that particular thing. So this SQL, it is used to get the data. That means we have to retrieve the data in the form of queries, and you can update the data. This users table, you can update the user as inactive or active, or you can add the age, address, like that. You can update or insert new user, right? And this is what user is one table. You can create another table like customers or some other, whatever the table you need, you can create this table. So if you think that some table you don't require anymore and you don't use the data anymore, you can delete that data. So it is used for table creation and table deletion as well. And if a lot of people uses this, you can limit the permission. So only you want a specific people to use that table, then you can do that. You can give permissions to a particular user, right? So and it's the universal language that we are using for the querying the data across different SQL platforms. So how does this because see, you have these applications in different very large domains that you have this data analysis, and you use this for the reporting and for maintaining these databases, and you have this AI. So how does this started? So how the SQL has started right in 1970s. So it was developed right in the 1970s, and then it was standardized across the years like 86, 87, and then it got versions. Every time it got version and it got updates, just 92, 99, 2003, and currently we are using the SQL version 2022. So every time, every year there is a new enhancement. This will be increasing, and how this works, and how the SQL works. Right? This is because the SQL works basically on majorly three portions. So the first one is SQL engine. So what is this SQL engine? What is this SQL engine? So it basically it passes your command. So whatever the query that you have given, it will break down into different chunks, and then it will go into the database optimizer, and it figures out the fastest way to get the data. I mean, so you give a query and it takes what is the fastest way to get the data. So let us say you want to go to a place and you ask Google Maps to find the fastest route. So it gives you the route which take you to that place in the fastest way. Similarly, the database optimizer will do the same. And finally, the execution engine. This particular execution engine, it fetches the results, and whatever the results that you have, it fetches from the database and sends to them. You don't have to write any complex code like that. So you just need to command them like get me this, filter that, or join this, just in your human words. Just like a unlike Java or Gojang, like this, you don't need to write any complex code. So why SQL? Why it is so powerful? Because it's very user friendly. You can learn it in with English. It's you don't need any specialized skills for SQL. You just need some basic understanding. So it can handle a millions of records, and you have indexes. So when we have billions of records, we place indexes on a particular column. If you want to query a particular column, it can get from that based on that index. This is fast. So it is mostly used, I mean, it's widely used anywhere. So for dashboards, for web applications, reports, automation, and there are many applications where this SQL is used. And it's definitely the in-demand skill and all the time. Whatever the AI you choose, whatever the stack you choose, wherever you go, the basic is SQL. Without SQL, there is nothing. So if you understand SQL, you can manipulate data. That's the most powerful skill in a data-driven world. So what is ETL? So we hear this name a lot of times. So what is ETL? So ETL simply stands for extract, transform, load. Just as I said earlier, you buy vegetables, you organize them, and you store it in your fridge. Just like that. So you extract everything from different places, and you using this SQL or any other tool, you clean this, you transform this, and if you want to do some calculations, you do that, and then you store it in your final warehouse. So final warehouse. A warehouse is a place where you store all these things. So SQL plays a major role in every of these stages. It helps you to convert this raw, unclean data into a structured and meaningful information. So if you know this SQL, that means you can control, clean, and move data. That makes you incredibly valuable, whether as a data engineer or whether as a data analyst or whether as a data scientist. So SQL is everywhere. That's all for today. So just stay tuned for tomorrow for the next topic. And comment out in the section and what you feel more about this data and search and analyze this data. You are going to the Instagram, analyze this data. So that is what this data. So if you have any questions, feel free to drop in the comment section. I will reply out as soon as possible. And subscribe this channel. Feel free to ask me anything. See you soon.